DAX is really something that most people struggle with. I would say 98% of people that are in Power BI struggle with DAX. If you have a really good data model, you're going to be able to take your basic understanding of filter context and DAX and make it go really, really far. Building a good data model is absolutely crucial, absolutely critical for data and analytics. In fact, in my opinion, building a good data model is the most important thing you can do in Power BI. My name is Mitchell Pearson, and I'm a consultant and trainer here at Pragmatic Works. You don't need to have 20 years of data modeling experience to build a good data model. Honestly, all you need to do is understand the fundamentals and the basics of the star schema, understanding facts and dimensions, and that is exactly what we're going to cover in this course today. We will have a Q&A session immediately after this live event. So make sure to send in your questions, put those in the chat window, watch the chat window, and make sure to show up for that live event so that you can get your questions answered or hear the questions that other people have as well. All right, so as we jump into it, the first thing I want to talk about here is the agenda. As I mentioned before, we're going to jump in and we're going to talk about the dimensional model. We're going to talk about the star schema. That's going to lead us into talking about fact tables and dimension tables and exactly what those two tables are and what they mean for your data model. We're also going to talk about multiple fact tables. This is a question that comes up all the time when we're teaching this in our DAX class or whether we're doing other engagements with our customers. Unfortunately, sometimes it comes up 6 months down the road after a data model has already been built and the customer is unable to really integrate that new fact table into their data model. So we want to talk about these very important attributes of a data model, and I'll talk about that in just a moment. The other thing we're going to talk about today is role-playing tables. How do you deal with a situation when you want to be able to analyze your data by the ship date and the due date, or you want to be able to analyze the data by the bill to address as well as the ship to address, right? The location of the customer. Very important analysis that needs to be done there, and there's a specific way we want to handle that inside of Power BI Desktop. Finally, the last thing I want to talk about, which is really important, and we're just ever so slightly going to broach on this topic today, is understanding the data analyst of the future. The data analyst of the future is really going to need to understand at least the basics of Microsoft Fabric and what that means to your organization and to your data and analytics. And so that's really the topic for today. The other big thing we're going to cover today is we're going to talk about how to build your data model in a demo inside of Power BI Desktop. Now, there's other ways and other methods you can use for building out your own data model. But if you don't have those means because you're a self-service BI person, you can do it inside of Power BI Desktop, and we're going to cover that in this session as well. Another thing I want to point out as we're jumping into this is that there's really two books that I recommend. I recommend the Data Warehouse Toolkit by Ralph Kimball. It was the first book that I ever read around the data warehouse, the dimensional modeling design. I love that book. It is a keepsake. It is a book everybody should have. However, another book that I recommend, and I actually recommend it first, is a book called The Star Schema by Chris Adamson. It is an awesome book. It is a lighter version of the Data Warehouse Toolkit. It is more understandable, especially if you're new to the methodology of data warehousing and dimensional modeling. So those are two books that if you really want to dive deeper into the world of dimensional modeling and star schema, I highly recommend. Make sure to keep a look at the comments and we'll post some links to those books there as well. As we jump into this topic of dimensional modeling, which is a specific type of modeling just for reporting off of your data. There's many different types of modeling that exist out there for different purposes, but dimensional modeling is specifically for reporting purposes. I want to talk a little bit about attributes that make for a good data model or attributes that make for a good dimensional model. The first one is that your model should be easily consumed and understood, because a lot of times we're building these data models in Power BI or in SQL or in Azure, and we ultimately want to open it up to the end users. We want the power users, the people within the organization to feel empowered to build their own reports. But if they look at my data model and it has a bunch of tables in there, too many tables, and they're not named well, it's not easily consumed, it's not easily understood, we're not going to get the adoption from the report that we're looking for. And unfortunately, that means that at that point, we are not going to have a good data model. So it's always important from the very beginning that we have a data model that is consumable, that users understand, right? Those are going to be the first things. The other thing we want to look at with a data model is that large data changes are scalable. What that means is that as data volumes grow, your model continues to perform well. Another thing we want to talk about is that the data model gives us predictable performance. And what predictable performance means is that if I open up a report and I run the report and it runs in, sub-second time, so 0.3 of a second, I expect that it's going to run in 0.3 of a second every time I run that report, regardless of what my filters are. The other thing that's really important, and this is probably the most important one here, oddly enough, but it is that we want to have a data model that is flexible and adaptable. Now, what flexible and adaptable means is that we can add to it over time. Most of the customers that come to me in virtual mentoring sessions, they either have very complex DAX problems that they're trying to solve, which most of the time we could have solved if the data model was just a little bit better, or they've really done a great job of building some awesome reports. And the end users, there are going to be a lot of people that are on this call right now listening to this, and they're going to be, this is going to resonate with you. The end user comes to them, the people that are consuming the reports, and they say, hey, we love this, but we want to also be able to see the data by this. And you go out there and you try to bring the data in, but you can't think of any logical way to connect the new data with the data that's there. That is a problem of flexibility and adaptability where the model can't scale as we go and we add new sources. We never want that. And the beautiful thing about the dimensional model in the star schema is that it is going to handle those situations automatically right out of the gate, because we're going to build our tables from the beginning so that it can handle those changing conditions over time. So that's a beautiful thing. But all of these are great attributes of a good data model. And there are more, but these are the ones that we're going to kind of focus on here as we're jumping into this session. So why do we want to build a good data model? Other than some of the things we've already talked about, what's easier with a good data model? I love this question because it's very easy to answer. If you have a really good data model, managing storage constraints, not overloading your data model, running out of space, because we are limited. If you really understand Power BI and the way it stores stuff in the data model in the background, we're limited with how much data we can get into Power BI, right? And so we want to build out the star schema so that we do reduce some redundancy in the model so that we can store more data in our model. Another thing that is really important here is building a really good star schema or dimensional model should help to improve performance overall in your model. And this is going to happen for a lot of reasons, and it's going to happen very organically. As we get to the situation where we have to write DAX, a lot of complex DAX that I've had to write for customers and help them with is generally the result of a model that's not really optimized for the situation. So if you have a really good data model, we don't have to write really complex or author really complex DAX calculations. So therefore, the performance of your reports are just going to perform better. Managing row level security. I work with a lot of customers. It's crazy how many customers, I mean, it's not crazy and it is, but a lot of customers are really worried about row level security. Being able to add into their data model the ability for certain users to only see the data that we want those users to see. This is perfect because we want to have one big model that really suffices for all of our different users, right? That's what we want, but we need to be able to put security in there. And if you have a really good data model, row level security is going to be a lot easier. And then finally, and I've already alluded to this a little bit, authoring DAX. DAX is really something that most people struggle with. I would say 98% of people that are in Power BI struggle with DAX. So if that's you, you're not alone. I love DAX. I enjoy it. I get to work with customers every single day on DAX. So it's just something that I really enjoy. Most people don't. And if you have a really good data model, you're going to be able to take your basic understanding of filter context and DAX and make it go really, really far. So building a good data model, everything is essentially going to be easier in Power BI Desktop if you have a good data model. That's why the session that we're doing today is going to be so important. Now, when we're talking about Power BI Desktop and we're talking about the dimensional model in a lot of ways is synonymous with the term the star schema. And so the star schema is called that because once we've added our tables into the data model and we've defined them, our facts and our dimensions, which we're going to talk about in just a moment, they kind of just resemble a star, as you can see on the screen. The fact table is generally going to be in the middle of that star, and it's going to be surrounded by the dimension tables. The dimension tables are what filter our fact table. And the fact table is ultimately going to be the mini side of that relationship. So generally the relationship, and this is ideal, and this is what we're going for, the relationship between the fact table and the dimension tables is ultimately a one-to-many relationship. Meaning that whatever you've built the relationship on, customer key, date, product key, geography key, whatever you've built the relationship on, the one side is the dimension. So the key that you built the relationship on is 100% unique in the customer table, in the date table, in the product table. But of course, in the fact table, every time you have a transaction that you're recording, you're going to record that customer. So the customer might show up multiple times. The date might show up multiple times. The product might show up multiple times. So the fact table is the many side of that relationship. And we'll get into that a little bit more as we get further into this course. The Snowflake schema is really a variation of the star schema. Our goal when we're building a data model from the very beginning, our goal is to keep it as simple as possible. A good friend of mine, he got me in this field over 12 years ago. He's moved on. His name is Dustin Ryan. He's off at Microsoft. He was very pivotal in the beginning of my career. And I remember a piece of advice that he gave me early on. He said, Mitchell, when you're building a data model, it never gets simpler. It never gets less complex. So from the very beginning, don't overcomplicate your data model. Make sure that it's understandable, it's consumable, and that it's going to be flexible and adaptable. You can build to it and you can add to it. And so at the very beginning, if we add in too many complex requirements, it's going to be very difficult to grow and maintain over time. And so we want to stick with that star schema as much as we can. However, when you get into a mature BI environment and you have 5 or 6, 7 fact tables, you have 20 or 30 dimension tables, this has really grown over time. Eventually, you're probably going to have some variation of a snowflake in your data model. So even though snowflakes are something that we are going to try to avoid to some degree, it is very probable that at some point you will have it. And in fact, I'll show you an example of that in our demo later in this session. So what is the snowflake? The snowflake is when your dimension table that is filtering your fact table is not only one join away. So in this example here, my geography table is filtering down my customer table, and then my customer table filters down my fact table. So if I want to be able to look at those transactions, those interactions, those events based on the geography, based on the country, based on the state, I have to filter from the geography table, which filters down the customer, which filters down the fact table. Now, a great exercise here is to look at the data model for just a moment and think to yourself, what is a different way that I could have modeled the data so that it's not snowflaked? And in this situation, there actually is a really good way to do that. We'll talk about this a little bit later as well when we get into our demo. But if you already have some ideas, feel free to throw those in the chat window. Love to see what you're thinking about as we're kind of diving into this. From a very high level, there's really 3 different model types that we kind of work through as we're working in Power BI. We have the conceptual model. The conceptual model is very high level. It's just the names of the tables. At this point in the development phase, we're kind of looking at all the reports, we're looking at all the data, and we're just trying to put on a whiteboard, put in an Excel document somewhere, all of the tables that we see that are eventually going to be part of our model. Then we move on to the logical model. The logical model is where we start to add the columns into the tables that we've defined. So we've defined a customer table, a product table, a geography table, all of these different tables, and now we're starting to identify exactly what attributes or what columns are going to be in those various tables that we're working with. Finally, we have something called the physical model. We don't get heavily into the physical model in Power BI Desktop because the physical model has all of the metadata information. Is a column nullable? What are the foreign key and primary key relationships between the tables? These are things that we normally define and store back in a database. And if you're watching this today, it's very likely you don't work a lot with databases and you've possibly never even built a table on a database, and that's okay. In Power BI, we primarily are going to work with the conceptual model, and that's kind of where we start. That's where the idea and the conception of the model begins, and then we move on to the logical model, where we start defining those columns and those attributes and putting that into the data model. So those are the 3 types of data models that we're going to be working with. I'm going to show you in the demo how to do a conceptual model quickly, and then we'll move on to the logical model. So this right here is an example of a conceptual model. We have our table names. We've looked at the data, we quickly pulled out what we thought was going to be our measurable items or our fact tables, and then we have our dimension tables that are surrounding that conceptual model. Before we get into our demo, I want to talk more about some dimensional modeling terminology. But the dimensional model is a logical way of organizing our data so it's easy for reporting purposes, period. That's what it is. That's what a dimensional model is. It's a way of organizing the data for easily being able to report on data. If you come from a database background, you come from a report building background and having to write SQL queries against databases with hundreds or possibly thousands of tables, you can appreciate more than anybody else the dimensional modeling concept, because our goal here is to reduce those hundreds or thousands of tables down to a very small number of tables that are built specifically for reporting and analytical purposes. Within the dimensional model, we have two primary types of tables. There's some variations of these tables, but we have two primary types of tables. We have the fact table and we have the dimension table. A fact table is effectively an event that we are measuring, and it may or it may not include measurable items, right? So the most common example you'll see in most classes and things online is sales, because most people, everybody can at least to some degree resonate with this idea around sales. And so if you're tracking transactions, you're tracking sales, it is a measurable item that has a measurable feature within it, right? So every time we record a transaction, we record the sales amount. That's something that we sum up. That's something that we add. It's additive, right? So that would be a fact sales table. But it could also be things that are maybe don't have a measure. So you might be counting the number of interactions that you have with a member. I have a healthcare company that we do a lot of work with, and they count the number of interactions with a member, whether it's through an office visit or a phone call or an email. There's no dollar amount that they're measuring. There's no minutes. There's no duration. They're literally just doing a count. And I see this a lot in healthcare and education where it's a lot of counts, a lot of distinct counts. So that works for this situation. The dimension table is really a category that we use to explain our dimensions or to explain our measures, rather, to explain our fact tables, right? So if I come to you and I say, hey, we have $5 million in sales, you're going to say, that's great. And then you start asking questions. Was that for this year? Was that for this month? Was that for ODL? Was it for Pragmatic Works boot camps? What was that for? And each time you ask one of those questions, well, the way we answer those questions is through our dimension tables. So I might have a product dimension table. So any question that I have that is product related, product color, product size, product weight, product price, right? What price category did it fall into? All of those questions I would answer from my product dimension. If I want to ask for what year, for what quarter, for what fiscal year, for what month, any of that information there, I would go and look at my date dimension table. And from my date dimension table, I can slice my fact table and find out that exact information. And so you have your fact tables, that's measurable information. And then of course we have our dimension tables. And then finally within a dimension table, we have our columns. Now, a lot of times you'll hear me, because of just various technologies within Microsoft that I work with, you'll hear me calling those columns attributes. It's kind of the same thing. An attribute is a column on a dimension table that we're using to effectively describe information. So let's focus a little bit more on fact tables specifically. To make this even more clear, I believe it is a business process. It's the process of a transaction. It's the process of an event. It's an individual event that occurs. A student taking a class, a claim that was submitted on an automobile, a claim that was submitted for a member at a healthcare institution, a member going to an office visit at a doctor's office, right? The return of an item. You buy an item, you return an item. The returning of an item is a different event than the purchasing of that item. So those are all events that we might want to measure that may or may not have measurable attributes associated with them. Now, one thing to ask about when we're looking at this is, what if you have a big Excel sheet, right? And this is where a lot of people come from when they're working inside of Power BI desktop. In fact, I see this a lot. One of the services that I do and I love, it's one of my favorite things to do, is something called a hackathon. This is one of the things we do with our customers. And the customers come in and they say, Mitchell, we want to learn about data modeling. We want to learn how to Power BI, but we want to learn it on our data. We're healthcare, we're manufacturing, we're education, we're finance, we're all these different things. And we're like, well, we don't have specifically healthcare data to train you on. However, we can train you on your data and we can build a data model with your data. And we do that through a service that we have called a hackathon. And we do these hackathons every week. If you want to know more information about that, make sure to go to pragmaticworks.com, check the chat window, and call us up and see if that model works for your company. But one of the things that we see with customers all the time is they have a lot of Excel data and they want to transition that Excel data into Power BI desktop. And we have to completely change the way that that data is structured, because Power BI is going to work with that data better if it's in that dimensional model or if it's in that star schema format that we've been talking about. And so they come in and they got this big Excel sheet that has sales in it and has returns in it and has other information in it. And now we're like, okay, we got to break this out. So here's a question for you. If I have in a row, if I'm tracking both sales and returns, then what kind of fact table would I have in Power BI? It's a little bit of a trick question because it's not a single business process, it's multiple business processes. In fact, if you have both sales and returns, it's two separate business processes, which means we have two separate fact tables. And it is okay to have multiple fact tables in your data model. In fact, this is one of the most commonly asked questions that I get. If you have a mature Power BI model and you've been maturing this over time and adding to it, you would have more than one fact table in your model because you're supporting multiple different business requirements, data and analytical requirements, and it's growing. You'd have a fact returns table, you'd have a fact sales table, and that could grow significantly into other fact tables that could be answering questions that you have of your data. So a fact table could be anything from like a claim amount, it could be a student taking a class, screenings that you're doing, it could be total claims, it could be cost, it could be sales, it could be returns, it could be the duration of a phone call, right? The megabytes used, if you're a telecommunications company, people are on their phone, internet, how many megabytes, gigabytes were used. All of that information is stuff that we want to track, that we want to add inside of our fact tables, right? And so this is all fact table relevant information. Now, the one thing about measures, your fact tables, is that they're generally sliceable, meaning that it goes back to that question I asked earlier about if I had 5 million in sales, you would come to me and be like, what product, by what carrier, by what shipping company, by what date, by what customer, whatever it is. And I would answer those questions with the dimension tables, right, that we've built and that we've designed. One more thing about fact tables that's really important. This part is not to be overlooked. When you build a fact table, generally speaking, you want to build your fact table at what is called the lowest level of granularity. The granularity is simply saying at the lowest level of detail. And so when you're working through an enterprise level data model, so I told you before, I've been building data models for over 12 years. I was building data models before Power BI Desktop was Power BI Desktop. I was building them at an enterprise level in SQL Server. When you are building a data model, there's really a 4-step process that you go through. And the most important step, in my opinion, in that 4-step process is defining the grain statement on your fact table. What does one row represent? So stick with me for just a minute because this is really important. If I look at a transaction that occurs at a store, and a transaction can have multiple items on it, but then in my fact table I put in there, on this date, this customer purchased this amount, so purchased $100 worth of product, and that's all I put in my fact table is at the transaction level, and then I build out an entire data model around that, and then I publish that data model, and users start to connect to it. One of the first questions they might ask is, okay, we have millions of dollars in sales, but by what product? By what product do we have those sales? And then they go to slice the data and realize, well, we don't have product information. And you say, well, Mitchell, of course we do. No, we don't, because our grain statement was just the transaction level. Now, if we wanted to see product, we have to go down to a lower level. That means that our grain statement has to be more detailed. One row in my fact table represents a line item on a transaction by product, by customer, by date, etc. If you have 20,000 transactions, but you average like 7 or 8 line items, you might have 140,000 rows in your fact table because you're recording every individual line item. Now, granularity is very important, and I'm going to tell you a couple of reasons why. One, if you store your data at a higher level, you lose what's called dimensionality. Meaning that if I store the data at the year level, at the month level, at the quarter level, at the transaction level, I lose dimensionality, right? I'm not able to filter by product like I just explained in that little quick example. We always want to store the data at the lowest level of granularity because we never know how the end users are going to slice the data. We just never know. I don't have any idea how they're going to slice the data and filter the data and what questions they're going to ask. And we want them to adopt the data model. And so if you build a model where you store the data at a higher grain, not at the most detailed grain, you might get into a situation where your data model doesn't suffice. It's not sufficient enough. And I have, when I was doing consulting and only consulting, back before I started doing training, I've had to go to customers who worked with another company and they built a data model and they worked on it for 6 months and they published it. They pushed it out to their end users and realized it was not going to answer the questions they needed to answer. And I would come in and we'd redesign the whole thing. We would rebuild it so that it would answer those questions. And so it's safe and it is recommended to store that data at the lowest level of granularity. Very, very important to understand that concept, because if you do this wrong, more than likely you have to start over. Before we get back into our demo, let's talk a little bit more about dimensions. A dimension table contains descriptive attributes that define exactly how your facts should roll up. We use our dimensional attributes to describe the data, as we've already talked about. Ralph Kempel said that dimensions provide the who, what, when, where, why, and how context that surrounds a business process. When we're looking at the dimensional architecture, if you will, of a dimension table, it's very different than a fact table. A dimension table is generally going to be very wide. It's going to have a lot of columns. So anything, if we say that a dimension table is a customer, anything relevant to that customer, we're going to have in that dimension table. Anything that's relevant to our business for data and analytic purposes. Their birthday, their age, their number of kids, number of cars, their gender, their demographic information, anything that's relevant. And I've worked with, I feel like every industry you can imagine, and I've seen that these different industries really value these different attributes to be able to identify areas of opportunity, to help customers, to screen customers, etc. Right? And so anything relevant to that customer is going to be in that dimension table, and it's going to be very, very wide. You look at your product table, you'd have product size, product category, subcategory. Things that you might, if you come from other types of data modeling, more relational, more business supporting data modeling, you might think, oh, I would separate those out into multiple tables. But in dimensional architecture, we generally going to take any of that related information that are part of that same category, we're going to put them all into one table. And this is what keeps the number of tables in our data warehouse to a minimum, so it's more understandable and more consumable, going back to one of the very first points that we made around the dimensional modeling design. Also, inside of your dimensional tables, you're going to have what's called a primary key or your natural key that comes from the source. So it might be the customer ID, the product key, the date table. Generally, you just use the date or a date key that you create. And so inside of a lot of our dimension tables, we have a natural key that comes from the original source. There's also something known as a surrogate key. And a surrogate key is a unique identifier that's designed in the dimension table that has no relationship back to the source where you pulled the data from. So if you pulled the data from Dynamics, you're creating a brand new key in your data warehouse that is unique to your data warehouse. This is to support more complex design implementations that you may have in your data warehouse that we won't talk about in this 2.5-hour course. But when you get into looking at the data warehouse toolkit and the star schema, you get into what are called slowly changing dimensions, storing historical information over time. Understanding that surrogate key, that unique identifier that is unique to the data warehouse, very important because it helps to facilitate those types of relationships. The other thing I want to point out when it comes to dimensional models is the best attributes are descriptive and they describe your data. That's very, very important. And the reason it's very, very important is because I've gone to customers where you walk in and they're looking at a report and they got sticky notes all over their monitor and it has a code and it has a name or a description. And I'm like, what are those sticky notes? And this is true story. And they're like, well, when the reports are built, when I'm reading the report, I don't know what the codes mean, so I have to write the codes down so I understand how to read the report. That's never what you want, right? So having a lot of codes and things that are understandable to one part of the business but not other part of the businesses usually aren't going to be the best. So we want to have descriptive attributes that describe the data so that when you're building reports, it's very intuitive and obvious to everybody. A lot of times your dimension tables will also have start and end dates on them. You know, what time was that product active? How long was that customer active? This is also 2 columns that you would need to understand if you're doing slowly changing dimensions where you track historical information. So that is very important. The other part that is really relevant to dimensional tables is having Boolean columns, true, false columns, flag columns, right? So for example, if I'm doing some analysis on my date table, I might want, or my cells, but I want to know what are all of our cells during the holiday season. Well, in my date table, I might have a flag that simply says true or false is holiday season. And so I can just say, boom, there I go. Or I might have a flag on is weekday or is weekend or is holiday. So you have a lot of these true-false flags that make it a lot easier to facilitate the analytical queries and analysis that we want to do in our data model. So it's very common to have those flag columns inside of our dimensional table. All right, well, that's it. That's our introduction to dimensional modeling and data warehousing. Now we're going to jump right into our class files and talk about the files that came with this course. So make sure that if you haven't already, you look in the chat window, go ahead and download these class files. And then we're going to dive into how to actually build our own dimensional model inside of Power BI Desktop. These class files right here are what you're going to find when you download the zip file for this Learn with the Nerds event for this course on our YouTube channel. And there's quite a few different files here that you're going to be working with. The first is going to be this Power BI file right here that is going to be our starting file that we can open up and that we can work with in this course. We're also going to have a completed version of the file that you can work with. And then finally, we're going to have a completed version of the file that also has the DAX calculations built into it. The sales and the fact budget are going to be our source files for this course. And so that's where we're going to be connecting to pull the data in. And this is going to be the data that we are cleaning and transforming in order to build out our conceptual model and ultimately our star schema in this course. And then finally, there is a PDF, and the PDF file that you'll see right here, that PDF file is going to be just a PDF of the PowerPoint presentation. So if you want to go back and look at some of the stuff that we talked about and discussed in the PowerPoint, you will have that PDF right there available as well. So make sure that you go ahead and download those files from the chat window in this YouTube event. If you're watching this after the fact, go down into the description of the event and you can download the class files from right there because this is going to be necessary. And then make sure immediately after downloading the files that you go ahead and unzip those class files so that you have access to the files. That's a step that gets missed very often, and it does matter, especially when you start connecting to the data. So make sure to unzip those class files and put them somewhere that you will have no problem finding them when you get into the demo yourself. All right, now that we've taken a look at the class files, we're going to jump in and we're going to go ahead and walk through the process of creating our conceptual model. The first thing I want to note as we start to get into the demo section of this class is that I typically am going to go a little bit quicker and a little bit faster through the class. This is recording. You're watching it either on our platform or on YouTube. Feel free to slow down the speed or feel free to pause the video and then play it again. But I am going to go just a little bit quicker because I want to get more information into this condensed section. So the first thing that I want to do is, now that we're getting ready to get into the demo, is really start to look at the data that we want to do our analysis on. And we're going to be starting with that sales.csv file that we talked about earlier when we were looking at our class files. So the first thing that we do in this section is go ahead and open up that CSV file so we can really start to get a feel for the data that we're looking at. So now I'm taking a look at the sales data here, and what we have is everything is in one big flat worksheet. This might be a little bit different for you. Maybe you're connecting to Dynamics or some kind of ERP system or SaaS provider, and instead of looking at one data source, you have 20 or 30 or 40 or 100. And it's a little different situation. The process and the explanation is actually the same. We want to create our facts, we want to create our dimension tables, but instead of taking a flat table and separating it, you're taking many tables and you're actually going through the combining operation. So I help customers on a regular basis with both of these situations, right? This situation here today is going to be an Excel file. And what I want to do is start looking at this and start identifying within this table what are potential fact tables and potential dimension tables. Now, the way that I normally do this is you can whiteboard this on a wall in your office or with your coworkers or your team, or you can just open up a tool that allows you to build out what would look like a dimensional model, a data warehouse. In this situation here, I'm going to open up another version of Excel, a blank worksheet, and I'm going to use something called Smart Art. I love this. It's easy, it's flexible, and it just gives me a visual cue of exactly what the data model is going to look like. So now that I've opened up a new version of Excel, I want to use, like I said before, Smart Art. And I do that by going up to Insert at the top, and I'm going to click on that right there. And what I normally use here is I use this cycle capability, and I'm just going to choose one of these here. It doesn't really matter. I'm trying just to get a visual representation of my fact table and the surrounding dimensions for the data warehouse that I want to build. So I'm going to grab this one right here and click OK. And then I'll typically go through the process of making this a little bit bigger. If you want to play with the formatting and change the colors, that is going to be up to you. Now, what I'll do is I'm actually going to minimize this screen so we can kind of look at this screen right here while we're looking at our data in the background as well. So I'll pull this down just a little bit, and then we can look at the data. Now, as I'm going through this, feel free to pause the video and think through this yourself. What do you think the fact tables are? What do you think the dimensions are? And then come back and see if you aligned with exactly what I came up with myself. As I start to look across this, the data that we're looking at is actually going to be data that is related to sales. It's related to transactions, right? So we know that we're working with sales data. So that's going to be my fact table. Remember, the fact table is in the center of that star. So I'm going to just put right here that we have our sales data. And now we get to the point where we ask ourselves, how do we define sales? What are the different dimensions that describes the data that we're doing analysis on? The first thing, if I'm going across the column headers here at the top, is we see that we have information about the product. So if I have $5 million in sales, I want to know by what product, by what category, etc. And so that is absolutely going to be a dimension. So I'll come in here and say, all right, I have my DIM product table. And when I'm in the process of building out my conceptual model, I'm going to use terminology like DIM, because if I have a lot of tables that are part of this data warehouse, I want to be able to quickly differentiate between my dimensions and my fact tables. Now, there's other information here as I'm looking across. I have product ID, and I start seeing other stuff that's related to product, like product, category, segment. We'll come back to that in a moment. The next thing I see here is I have information about the customer here. So we have customer ID and some other information. So we know that we're also going to have a DIM customer table. So I'll do DIM customer here. So now I can do analysis of my sales based on the customer information. We have information about manufacturer. Manufacturer unit cost and unit price are very tricky. We'll come back to that in just a moment. And then we have stuff like zip code, city, state, and region. What I'm going to do in this situation here is I'm going to come in and I'm going to add another dimension over here for campaign. So I'm going to call this one my DIM campaign. A lot of times when I'm doing this demo, I'll leave campaign out, so we can add it or we can leave it out. That's going to be up to your data model and what kind of questions you're trying to answer. If you're trying to answer questions like how successful was that marketing campaign in driving actual sales or whatever it is you're measuring, then that's going to be pretty important to add into our data model, of course, right? So DIM campaign is going to be very important here. Another one that we might see as we're working through this is DIM geography. Geography is a pretty obvious one. The problem with geography is you can add it in a few different places. So we're going to have a little bit more of a conversation around geography when we get into building the model. But absolutely, I can come over here because we have city, state, region, district, country, and I can put all of this into my geography table. So we'll do DIM geography there. All right. So far, so good. We have a good looking model. Now, you might have noticed that I kind of ran out of spaces within the SmartArt to add additional dimension tables. That's true. If you want to add additional dimension tables here, if you want more than 4 circles, all you have to do is come over into the properties box, which was already open. Whenever you have the SmartArt selected, hit enter here, and I can add in here my 5th dimension. All right, the 5th dimension. That sounds super important. Right, 5th dimension. So now I have a 5th dimension, whatever that dimension might be. And so we have product, we have customer, we have geography, we have campaign. Let's look at the data one more time. Let's see what else we might have here. So if I go back over here, we have customer, we got that. Oh, we need date. Date is actually a very, very relevant one. Every data warehouse, for the most part, 99.7% of them are going to have a date dimension. I've never worked with a data warehouse myself that did not have a date dimension. And when you're inside of Power BI, and we are talking about data modeling specifically for Power BI, when you are inside of Power BI desktop, we're doing a lot of analytics on time intelligence, time series analysis, year over year, year to date, prior year, rolling totals. You have to have a date table that has been specifically designed and developed with all of the rows of data so that you can do that type of analysis. So we absolutely need to go ahead and add in here as our 5th dimension, our DIM date table. So now we have our date, we have our customer, we have our product, we have our geography, and we even have information about campaign. Now, as you're looking at this, you might think, well, Mitchell, you have a product dimension, but you didn't create a category dimension. Isn't the category a different dimension than product? Well, remember, when we're building out the star schema, we're trying to consolidate as many related columns and attributes as we can into a single table. So remember that the architecture of a dimension is very wide, a lot of columns. Category, subcategory, generally speaking, I'm going to add them into the product table. And then if I need to make a change later, which we actually will as we get later in this video and in this course, if I need to make a change later, I can do it at that time. And I'll explain exactly why we might need to do that to support multiple fact tables. But for now, product category, if you're thinking about that, I would actually put it in the dim product table. So we'll leave that there. Unit price and unit cost are also very tricky. Where do you put them? Because if you think about the unit price of a product, the unit cost of a product, it changes over time. Today, the price of it today is not what it's going to be tomorrow and is not what it was yesterday. So if we're not having what we call slowly changing dimensions or dimensions that track historical information over time, then you really wouldn't put it in the product dimension. Where I would probably track that information is actually in my fact sales table. In my fact sales table, I would have the unit price, I'd have the unit cost, and I can go back and kind of analyze what was the cost of the product, the profit margin at that time when I sold that product. And I'm not really doing a lookup to specific products at specific points in time in the dimension product table. We are not going to get into slowly changing dimensions in this video. However, if you're interested in slowly changing dimensions, how to handle that in Power BI or Microsoft Fabric, let us know in the comments below. In fact, if there's any videos that you want to know about or learn more about that's really important to you, let us know in the comments below, and that'll prompt us to maybe do videos on that in the future. All right, so this right here, beautiful looking star schema. I love it. This is where that name, the star schema, comes from. The next thing that we want to do, once we have this conceptual model and we've conceived it, we now want to get into the demo and we want to start building it out. We want to start doing that. Now, maybe you're like me. You come from a consulting background. You're a BI professional. You're an IT person. And you're like, Mitchell, I'm going to do this in SSIS or Data Factory. I'm going to do this in my Azure SQL database in the background. That's awesome. Good for you. But most people coming to Power BI don't have that background. And so most of us in Power BI are going to do our cleaning up, transforming, and designing of this data warehouse actually in Power BI desktop. And that's exactly what we're going to do today in this course. So I'm looking forward to it. All right, now that our conceptual model has been conceived, we're going to open up Power BI desktop. If you've chosen to follow along, go ahead and open up Power BI desktop on your machine as well. The first thing I want to do is go to the home ribbon right here at the top. And from the home ribbon, I'm going to choose Get Data. And from the list, we're going to select text or CSV file. As you know, if you've worked with Power BI desktop before, which you probably have if you're in this course, if you have not, make sure to go take a look at our Introduction Beginner to Pro Power BI course by Devin Knight. It is amazing, and it showcases a lot of our other trainers as well. So if you're brand new to Power BI desktop, please go watch that one. I'm not going to cover all the basics here, but you will learn a lot if you're new to Power BI desktop. Now, when you go in here, you might have data that's in ERP, in Dynamics, in Salesforce, in multitude of different locations. There's a lot of built-in connectors to help you out with that. To make this class accessible to a multitude of people, we're going to be using a CSV file. So if you chose to go ahead and download those class files at the beginning of this class, you can follow along at this point. Remember, pause the video if you need to. I'm going to choose from this list right here a text or CSV file, and then we'll go ahead and grab that sales file right there. I did, prior to opening up Power BI desktop, go ahead and close out of that CSV file, because sometimes if you're opening up an Excel file, it's already open, a CSV file, you might have problems when you connect from somewhere else. So I went ahead and I closed it up just to make sure. Now I'm going to go ahead and click Open. And whenever you connect to a CSV file inside of Power BI desktop, we get this nice preview screen. And this preview screen gives us a preview of the data. And you'll notice that it looks exactly like what we were looking at a moment ago in our CSV file. At this point, I can load, transform, or cancel the data. 99% of the time, you're going to want to click on Transform Data. There is one more thing I want to point out real quick. If you take a look at the date field, you'll notice we have a date and we have the time in there. This is a date time. I didn't mention it when we were inside the CSV file, but inside the CSV file, it actually just showed a bunch of zeros, oddly enough. But it is a valid date, and 90% of the time, Power BI desktop will recognize it on its own. However, there are some instances where in your situation, it might not have recognized it properly and it didn't pull the data in. What you can do is open up that CSV file, format the date, save it, and then load it again. Hopefully that helps if you happen to be one of those one-off use cases where that happens. So what I want to do here is click on Transform Data. And when I click Transform Data, that launches the Power Query Editor, which is an amazing tool for cleaning and transforming data in Power BI Desktop. And most of the time, you will always launch the Power Query Editor. So we have this big flat Excel sheet. All of the data has been now pulled and brought into Power Query Editor. And what I want to do is I want to make some duplicates of this data, right? And that way I can start to build out our dimension tables and walk through the process. So let me give you a quick idea of what this process is going to be. We have our file, we're going to make a duplicate of the file, and then we're going to build one of our dimension tables, right? So maybe we build the product table first. Once I build the product table is going to have information in it like the product name, the category, the product ID. The fact table no longer needs that information. The fact table only needs the product ID because the category, the name, or any other relevant product information is in the product dimension. So remember what we talked about earlier, the dimension or the architecture, if you will, of a fact table is not very wide. It's very narrow. You have whatever metrics you're measuring and then the keys that relate back to the related dimensions. So they're not going to be very wide. So we'll duplicate the table, build out that product table. Once we've built out the product table, we'll go back to the original table that we had and we'll remove those attributes or remove those columns from that table. So let's kind of walk through what this process looks like together. I'm going to come over here and right click on cells, and then from the drop down I'm going to go ahead and click on duplicate. When I click on duplicate, I'll get a duplicate of that original table. I'm actually going to do this 2 more times. So I'll do it 1 more time, I'll duplicate it, and then I'll do it 1 more time again. The reason I'm doing this 3 times is because we're going to have a product table, a customer table, and we're going to have a geography table that we start with. So for the first one, if I go back to it right here, over here on the right, my applied steps show that I have a source, it automatically promoted the headers, and it changed all my data types. All 4 of my queries right now are at the exact same spot. What I want to do with the cells too is first I want to go ahead and give this a name, and I'm going to name this one dim product. This is going to be our product dimension. Once I've named this my dim product, the next thing I want to do is remove all of the columns that are in this query that don't relate to the product, right? So we're going to remove those columns. And so the way that I generally do that is within the table. Once the table is selected right here, I can come up to choose columns. And if I click the top half of this, it's going to show me a list of all the columns that exist in this table. And I'm going to go ahead and just unselect everything. And I'm going to keep product ID. I'm going to go down a little bit further and I'm going to grab product, category, and segment. Again, remember things like unit price and unit cost. I typically wouldn't keep in this product table unless it was a historical dimension table. If you go back and check out those books that I recommended, the STAR Schema or the Data Warehouse Toolkit, they will talk about those slowly changing dimensions. It's also a very important topic if you want to get your certification as well, but if you've been taking a look at our Cert XP courses at Pragmatic Works, we help prepare you for those certifications there as well. So it is important to understand slowly changing dimensions. Just in this small time frame that we have together, we're not going to get into that today. So I'm probably going to go ahead and just put those into my fact table directly. So if I want to go back and look at that cost or the price historically, we can get that information over there. And really for product, that's all I need. So I'm going to click on OK. And now we're down to only those 4 columns that we currently find relevant. Now, remember I said dimensions are typically going to be very wide. We don't have a lot of columns here because we're working with sample data set. But if you have a product that has 50 columns and it's all relevant and you want to slice your data by those 50 columns, that's awesome. That's amazing. I love it. No problem with that at all. Now, the next thing that we need to do is we pulled and duplicated this information from the sales table, right? In the sales table, anytime I sold a product, it has that product in that table. So I have duplicates in here. And remember we talked about the fact that dimension tables are the one side of the relationship. And what that means is whatever you build that relationship on in your dimension table, because it's the one side, that value should be unique. Unique. You can't find it anywhere else in that table. So if we look at the product ID, you can tell me right off the bat, this is not unique. That means our dimension table is not where it needs to be. So what we can do at this point is I can go through and I can multi-select all these columns. and then I can come in and I can remove duplicates. There's a couple of ways to remove duplicates in the table. If you click on this top left-hand corner right here, you have this little table icon. The table icon will include a bunch of transformations that you can perform at the table level, across the table. And so if I come down to the bottom right here, I can click on remove duplicates right there. You might know this already, but there is about 4 ways you can remove duplicates from tables in Power Query Editor. All of them are fine. Microsoft just gave you a bunch of different buttons that you can click to get there. So now we have a really good looking product dimension table. One thing I want to point out very quickly here that I don't necessarily think we'll get to in this class, but I want to point it out. We're in a good situation because we're creating this dimension table directly from the sales table, directly from that original worksheet, and we already have a product ID that exists. And we already know that when we load this in the Power BI desktop later, we're going to build a relationship from the product ID, which is now unique, so my dimension is the one side, we're good on that, to our fact table on the product ID. So we're in a good position, but sometimes when you're building out your data warehouse, you might not get a nice key that you can build a relationship on, unfortunately. So you might have to build that key yourself. And if you're talking about slowly changing dimensions, which we've already mentioned and brought up in this class, again, you might have to build that key yourself. So I'm going to show you how to build the key. This is not a necessity. I'm not going to keep it. I'm going to get rid of it shortly after we build it, but I want to talk through high level how you would do this if you needed to, because this situation does not require it of us. So what I would do is up here at the top under add column, I can add an index column. And that index column is going to give me a unique row identifier for every row that's in this table, 1 through whatever. I'm going to start from 1. So I'll click on 1 right there, and immediately I have an index column over here. I would normally rename this. I'd call it my product key. Again, it's a unique identifier. This is awesome, but here's the next question. Feel free to think about this yourself. How would you get this key into the sales table? Because it doesn't exist over there. That's an important question. If you were working in Excel and you had these 2 different worksheets and you needed to get that key into another Excel worksheet, another table, you would use a VLOOKUP or an XLOOKUP function, right? You would do a lookup. If you were in SQL Server, you would do a join. So what I would do is I would do a lookup on the product name, that should suffice here, to the sales table. So I'll do a merge. That's what it's called in the Power Query Editor. I'll do a merge. And then once I've found the related product in the sales table, I'll then add the key that we just created. Good? So remember, in this situation and in many situations, this might not be required. However, in this situation, it is. So I'm going to go ahead and click on added index. I'm going to get rid of that step over here in the applied steps. We don't need it. I just want to make sure to give you that extra information in case you are interested. So we're in pretty good shape right now. We have our dim product table. Now we're going to move on and we're going to create our customer table. So to create our dim customer table, we're just going to go down to that next query that we duplicated in our model. So I'll go over to sales 3. I'm going to go right over here to the properties and I will go ahead and call this one our dim customer table. Perfect. All right. So now we're going to do the same thing we did before. What was the first step we did before? I'll give you a moment to think about that. If you said remove all the columns that we don't need that are not related to the customer, you are correct. So congratulations. So again, I want to be on the home ribbon and I'll have my mouse somewhere inside of this table and I'm going to go ahead and tell it which columns I want to select. So I'll say choose columns. I'm going to unselect everything here. And then we're going to tell it what columns are related to our customer. So we're going to go with customer ID. We'll go ahead and grab our zip code. And I want to grab the email name. That's going to be important for this situation here. And this is where I want to talk a little bit about geography. Because I know this data model, and I know that the geography that's part of this Excel sheet is actually the geography of the customer. And so if I know that it's the geography of the customer, then you can just put the geography actually in the customer table directly. And that's a very popular thing to do in dimensional modeling, specifically when we're building these data models for data and analytics. And the reason for it is because a lot of times when you're building data warehouses, you may have multiple geographies that you're working with. So you have the location where something was purchased. Well, that has geography. And then you have the location of the customer who made the purchase, and that has geography. And you have the location of the warehouse where your inventory is, and that's geography. So if you just have a single geography table, how does it handle all those situations? That gets a little bit tricky. So if I know that I want to be able to analyze sales by people that come from the state of Florida in the United States, I can just go to the customer table, bring in the state, filter down to Florida, and get exactly what I'm looking for there. So it's very common to just put the geography into the dimension tables that you're going to be working with. So we're not going to do that here because I want to show you what the Snowflake will look like and have a conversation about that. So I'm actually going to build a separate geography table that does facilitate through the customer table in our model. So we have our zip code, we have our email name, country, district, region, state, and city is going to be in the geography table. So again, our customer table is not going to be super rich, just a few columns of data right there. So we'll go ahead and click OK. And that gives us this table right here. Now, before I go any further, once I've removed the columns that I don't want, the next thing that I want to do here is I want to remove duplicates from our data. So I'm going to right click after I've selected all of the columns here, and I'm going to click remove duplicates right here. Now you might be thinking, Mitchell, last time you removed duplicates, you did it somewhere else. You're absolutely right, I did. Remember, there's a couple of different ways that you can do this and many of the steps in the Power Query Editor. So we're going to remove duplicates. That gets us down to where we should only have one row per customer. And the next thing that I want to do is I want to clean up this email and the name. So the customer name is actually in this column, but for whatever reason, the vendor, the location where we're receiving the data has the email and the customer name combined into a single column. So I am going to right click on the email name, and we'll tell it that we want to split column by delimiter. So right click on the column that you want to split column by delimiter. That's going to open up a pop-up box. I am going to go with a custom option here because I know by looking at the data that we have that semicolon and then a space. And the semicolon space is what separates the email from the full name of the customer. So we're going to do that. I'll do custom, and right here, I'm going to type in the semicolon and the space, and I'll tell it essentially just the first occurrence. So if by some chance you have bad data and you have multiple of that delimiter, I don't want to create another column in my data model. I only want to grab the first occurrence. So I'll click OK. And that's beautiful. So now we have a full name column and we have an email column. And we do need to name these, but we'll do that in a moment. The next thing I want to do is I actually like to separate my name as well. So I want to have a last name and I want to have a first name column. And you can tell by looking at the data here that the last name is first, followed by a comma, and then the first name. So now we're going to do another delimiter, but the delimiter we're going to use this time is going to be a comma space. So we'll do the same thing we did before. I'll right click on email name, split column by delimiter, and I'm going to choose custom again. And the reason I'm choosing custom is because I want to do a comma and a space because we have that comma and a space there. So we'll do comma, space, and then I'll do leftmost delimiter, and I'll do OK. So now we have our last name and we have our first name. So I'll right click or just double click, and I'll call this one my last name. And then we'll come over here, we'll call this one our first name. And then for the email address, I do want to get rid of those parentheses. There's an opening parenthesis and a closing parenthesis. I want to get rid of both of those. And so what I can do is right click on email name and tell it that I want to replace values. I'll replace the opening parenthesis with just nothing. We replace it with nothing. Click OK. And then we're going to repeat that step again, and we're going to tell it that we want to replace values, and we're going to replace the closing parenthesis here, and we're going to also replace that with nothing, right? And we'll click OK. And so now this looks beautiful. The last step that we need to do here is rename this column to our email right there. So we are now completed our third dimension in our data model, our second dimension, our third table, but our second dimension in our data model. And now we're going to move on to the next step. So we've got our product, we've got our customer, and we talked about also doing a geography. So we're going to do that next so that we can see what that looks like in our data model later. So I'm going to go ahead and go down to the fourth table that we got right here called Sales 4. And we're going to walk through that process of building out this dimension table as well. And now, first thing I always want to do is I always want to give these tables a good intuitive name. So we'll go with dim geography here. And then I'm going to, as soon as I get done with that, I'll choose my columns. And we're going to keep all the columns that are related to our geography dimension. So I'll unselect all these columns, and we're going to go with our country, our district, our region, our state, our city, and finally our zip code. And that looks good. That's everything that we wanted there. So we'll click OK, and that's going to bring up the columns that we want. Now again, we have the same problem that we've run into before, which is I want to multi-select all of these columns here. So let me see if I can get that to start working. There we go. I'll do that one more time. My control button is a little bit weak there, but we got it that time. And now I'm going to tell it that I want to remove all of my duplicates. Now, personally, when I'm looking at this, we're going to actually build our relationship on the zip code. But if the zip code happens to share a duplicate for whatever reason, you know, a different city sharing the same zip code, a district, then we now have a zip code that we're building our relationship on in the geography dimension more than once. That means that our dimension is not the one side of the relationship, it's a mini side, because the key, the value, shows up in that table more than one time. This is a problem. This is probably one of the number one problems that customers run into when they're trying to build a data model in Power BI. How do I solve that problem? There's a multitude of ways of solving that. If we run across that problem, what I would do is I would go up to add column, add an index like we talked about before, so that I have a geography key that is 100% unique. And then I would get that geography key into the sales table by doing that merge operation that we talked about before. So whatever made this a duplicate, maybe it was the city plus the zip code, I would do a merge to the cells on city and zip code. So I'd join on those two columns, and then I'd put the key into the sales table so that it would be a one side of the relationship. I hope that makes sense. Very common problem that customers run into all the time. Sounds like a great follow-up YouTube video to me. All right, so with that part being done right there, geography is done. We're in a good spot. The last dimension table I want to add for now, and we could add campaign. I might skip campaign for now, but the one that we really need to add is the date table. And this is the one that doesn't really work. I can't go to my sales table and say, hey, let me duplicate the sales table and just take out of the sales table the date that lives and exists right there in my date table, my sales table. I don't want to do that because it could have gaps. It might not encompass the full range of dates that I want, so that I can do that time series analysis that we talked about, the year over year, the year to date, the rolling month total. So what we're going to do instead is we're going to go over to Devin Knight's blog, and we're going to copy out some code from his blog, and then we're going to put that code right here in Power BI Desktop, and we're going to build a date table from that. So we're going to go to devinknightsql.com, and from this website right here, and feel free to check the chat window, we'll drop that link in the chat window as well. But from this website, I'm going to scroll down to categories, and from the categories, I'm going to click on Power Query. When I click on Power Query, it's going to show me all of Devin's awesome blogs on Power Query, but the one that we want is going to be creating a date dimension with Power Query, and I'll click on that. If you're interested in what this code does and how this code generates the different columns in the table itself, what you can do is you can read through the blog that was provided by Devin. But all I'm going to do is come over here and I'm going to copy everything that's in this gray box from the very beginning to the very end. And once I've copied that code, I can take it back over to the Power Query editor and I can put this into a new blank query so that it generates a date table for me on the fly. This is really cool. This is a great option. So now that we've gotten the date table copied, or at least the code for it, we're going to go back over to Power Query Editor, and I'm going to go back to the home ribbon, and we can click on New Source. And what we're going to do is we're going to choose Blank Query, and there's actually quite a few. What we're doing right now, the process that we're going through, there's a lot of these scripts out there that people have created that you can leverage inside of the Power Query Editor to automatically generate these tables. So this is a really cool tip. We're going to go ahead and open up this blank query right here, and it's just going to be a blank query. There's no data, there's nothing there yet to populate. And what we'll do is we'll click on Advanced Editor, and when we click on Advanced Editor, it's going to give us this pop-up screen. And with that pop-up screen right there, I'm going to delete everything that's in it because we already have all of that structural code that we need in our Power Query formula language. And I'm going to paste in the code that we copied from Devin's blog. And when you're done pasting that code in there, you just go ahead and click Done. And what this does is right here at the beginning, it's actually going to create a function. There's a command in here that effectively creates a function that we can pass values into, because we're going to tell it what dates we want our date table to contain. So I'll go ahead and click OK right here. I'll click Done, and it gives me this function. So we do not yet have a date table, but we're almost there. The next step is to actually pass in our start date and to actually pass in our ending date. And so I'll go back to, probably go back pretty far. I'll go back to 2011, sounds good. And then for my ending date, I'll do 12/31/2024. Now you might ask me, Mitchell, why would you not go way into the future, like, 10 years or 15 years? If you do that, you do have to build in some logic into a lot of your reporting visuals and DAX to not display those future years when you're doing running totals and time intelligence and prior year. So that can be a little bit frustrating at times. I would rather just go to the end of the current year that I'm working with. And what you can do is once I click Invoke, it's going to create this date table for me, which we'll name in a moment. But I can actually, if you know the ILM language, you can actually make the date dynamic here so that once I switch over to a new year, it automatically changes to the new year. So the date table gets repopulated when I refresh my model and goes all the way to 2025. It's not very difficult. We won't do it in this video course here, but it is very easy to do. All right, so with that being said, you could also manually, anytime you want, open this back up and update it. I wouldn't recommend that. If you're gonna go with this route, you definitely wanna automate it in some way. Now, I'm gonna go ahead and name this my dim date table, because that's exactly what we wanted this to be. So dim date, and then I'll hit enter to rename that. So we're in a really good spot. This is the point in this course where I want to go ahead and, there's actually a couple things we do need to do. We're missing a couple steps here. The first thing I want to do is go ahead and change all of the data types here and make sure they're all defined. And then we want to go back to our sales table, and we want to remove any of the columns in the sales table that are not relevant, that are not going to be used because they're in the dimension. Like, I don't need product name in the sales table because it's in the dimension. I don't need customer name, customer email in the sales table because it's in the dimension. So we're going to make that sales table narrow, removing a lot of those no longer necessary columns. And so the first thing we'll do is I'm going to go over to date, and we're going to make the date right here a date column. I'll go over to my year. That's going to be a whole number. So I'll click right here and make it a whole number. For quarter, we'll make that a text. Week number, we'll make that a whole number as well. Month number will be a whole number. And if you're thinking, Mitchell, can I multi-select and change multiple columns at one point? Yes, you can. But we do not have that many columns, so this does not take very long. All right, and this will be a text. So just make sure that as you're going through your model, if you're following along, that you change all of yours to kind of match what I have here. And then the next step is we're going to go back to our sales table, and from that sales table right there, we're going to start cleaning this up just a little bit further. Now, the one thing I do want to fix here, it can cause you problems when you're doing time intelligence later. I want this date column to not be a date time. I only want it to be a date column. So I'm going to change it to date right there. And it asked me, this is actually important. I didn't expect this, but this is perfect. Do you want to replace the current change type, or do you want to add a new step? So interestingly, if the original data source was like a text, if you go from text directly to date, sometimes it will actually fail and not work. So you have to go from like text to date time, and then you have to add a new step that changes it from date time to date. I'm actually not 100% sure if it will fail if I replace current, but I know it's a safer option to add new step. So to keep the video concise and not introduce any errors that we got to fix, I'm going to do add new step, but be aware that if you've done that in the past, and many people when I tell them about that say, oh, that's happened to me, if I add new step, it's going to work. I know it will work. I've done with this and dealt with this a lot. All right, so we did that. The next thing that we want to do in this sales table is remove the columns that we don't want. So we'll do choose columns here at the top, and then we'll start getting rid of columns we don't need. We know we need product ID and date. We know we need customer ID and campaign ID. We didn't create a campaign ID dimension, but we can always come back and do that later. Number of units sold, yes. Product, no. We don't need that. We don't need category. We don't need segment. Manufacturer is an interesting one. because you might want to have a manufacturer dimension, or you might want to put manufacturer into your product dimension. It really depends. I've worked with companies in almost any industry you can imagine through virtual mentoring sessions and hackathons over the years. And I worked with one company that did a lot of, they built a lot of units for items that went into surgeries, that went into patients. And obviously any kind of defective part or part that didn't last or had a problem is a big deal. And they got parts from different manufacturers. So same part, same piece that goes into something else. And so they definitely would track it. But if you get two parts that are essentially identical, made by different manufacturers, if you track that information in your product table, you now have to have more than one row. One row for this manufacturer, one row for that part for this manufacturer. So now it kind of introduces a different level of detail in your product table that then changes it from being a unique, that key, that product key is no longer unique because it's in there twice, right? So what you could do if that's a situation is you might go ahead and decide, okay, I need to know the manufacturer information. It's crucial for our analytical purposes. We want to know what manufacturers have defective parts or whatever it is that you're measuring. You might go ahead and just create a manufacturer dimension. And so it's separated from the product itself. It's just another dimension. That can present some challenges as well, but just keep in mind those are the options that are available. So I am going to leave it for now in my fact table since we didn't put it anywhere. I'm going to keep cost and price in my fact table, but I'm going to get rid of zip code. I'll get rid of email name. I'll get rid of city, state, region, district, and country. The reason I'm getting rid of zip code is because my geography is going to go through our customer table. So once we're done with that, we'll go ahead and click OK. We've really cleaned up this fact table. This looks a lot better. And the final step here is to save our work. We want to make sure that we save our work. So I'll come up to the very top and click Save. And when I click Save, it'll say, hey, what do you want to call this file? And I'm going to tell it that we're going to call this Learn with the Nerds Data Modeling Demo. And then I will choose where I want to save that file, and then we'll do Done. I'm going to save mine right here into my student files. You can save yours wherever you want, just as long as you remember where you can find that later at a later time. Generally, if you open back up Power BI Desktop, you can go into your recents and it'll show up right there as well, but definitely make sure to save. So once I click Save, what it's going to do is it's going to ask me, do I want to apply now or apply later? Typically, I'll just say apply later, and then inside the Power Query Editor, after I've saved, after I've filled it, all of my code and all the work that I've done has been saved, then I'm going to go ahead and hit Close and Apply right here in the top left. Now what Close and Apply does is it's going to close out of the Power Query Editor, and then it's going to run all of the compression algorithms. It's going to build the data model in the background. It's going to do all of the work. And then even in my relationship view in Power BI Desktop, it's actually going to go in there and build the relationships automatically that it thinks should exist within our data model. And so if I go over to the model view, anytime I load data into Power BI Desktop, when I get to this step, the first thing I always want to do, go over to the model view, look at the relationships that have been defined, and make sure that they are correct and see if there's any that I need to define myself. If I come over here, I can start to look at our data model and see how it's coming together. And what you'll notice is that we do not have a perfectly defined star schema right now because we do have a little bit of a snowflake. If I want to know my sales by country, my sales by state, I would need to come over to geography, pull in the country, pull in the state that I want to see. That would need to filter down all of the customers in that geography, and then that would filter down the sales. The other thing that I want to do at this point is I want to look at the relationship. And by hovering over that relationship between geography and customer, it'll tell me, hey, this relationship was built on the zip code column. That's what I expected. You'll notice that Power BI properly identified the geography table as the one side of the relationship, which means the zip code in that table is unique. You'll never find a duplicate. And in the customer table, there are duplicates. We have multiple customers. Fortunately, good booming business where we have multiple customers that live in the same zip code. The relationship from dim customer to sales is going to be on our customer ID. That customer ID is also a one-to-many relationship, which means, again, the customer ID in the customer table is unique, but yet every time that customer, a customer like Mitchell Pearson, makes a purchase, we record Mitchell Pearson's customer ID in the sales table. So it appears many times. So we have a one-to-many relationship, which is perfect. And that's exactly what we're looking for here. Finally, we have one other relationship that's already been defined and created. And this is going to be our dim product relationship. And if I hover over that relationship right there, I can see that that relationship is from product ID to product ID. And again, the iconography here represents that the product table is the one side of the relationship and the sales table is the many side of the relationship. So far this is perfect. Now the one outlier we have that we really need to fix is our date table does not currently have a relationship to sales. And that is going to impact our visuals. And what I want to do is just show you the impact that that has when you don't have a relationship defined in your data model. Or maybe you have built a relationship, but there's something wrong with the relationship. It wasn't built correctly. You have missing attributes. There could be a couple of different reasons why this would occur. But if I come over to my date table and I just bring in something like the calendar year, and I put that into, and it's doing a sum. We don't want that, so I'm going to move the year up to my x-axis, and I will go ahead and tell it that I do not want to summarize. Let me put that in the table. There we go. That's perfect. So I'm going to put the year into a table visual right here. And then from my sales table, I want to go ahead and just sum up the unit price. So let's sum up the unit price. We'll drop that right here. And you'll notice that we're getting some very odd behavior. Something that just as soon as you see it, you know immediately, well, that's not correct, right? And that is that we have apparently for every year that we've ever been in business, and maybe years that we weren't in business, we have $65,547,000 in sales every year, exactly the same number. So what's happening is that my date table, because it doesn't have a relationship defined in the data model, is unable to properly filter the sales table. So that automatic filtering that we love that happens in Power BI is not occurring here. But we can fix that in just a single click, right? If I go back over to the data model, and I know that the relationship between these two tables should be on the date column, I can grab that date column from the dim date, drag it over to the sales table, drop it right there, and then once I know that that relationship is correct, I can verify and validate it and click Save. That gives me a relationship here by looking at the iconography. Again, it's a one-to-many relationship. That is perfect. That is beautiful. And if I go back over to the report view, it's now working exactly like we would expect it to. It is properly showing us the total sales for each year based on the year that we're filtering on, which is exactly what we're looking for. And so that's how we build a relationship in our data model when maybe that relationship was not created automatically. Let me point out one more thing in this section that's really important about the date table. We have a date column that we are building our relationship on. This is a date column. It is considered a best practice to actually build your relationship on a numerical value, an integer value, like a key value, not a date, not a text field. And so if you happen to have in your data model an integer value like a date key that's in your fact table and your date, and you build a relationship on your date key, up until this point, everything's going to work exactly the same way. However, when you get to building like a year-to-date calculation, year over year later down the road, if you built your relationship on a date key, there's something very important you have to do. And if you don't do this, you're going to be like so many other people that are discouraged, that are in the Microsoft forums, that spend weeks trying to solve a problem that really wasn't their fault. All you have to do is come over to your date table, right-click on it, and mark it as a date table. So you mark it as a date table here, and then you specify what column is your date column in your model. So I can do this, and it's not going to have any effect really on my model because I built the relationship just on the date column. So Time Intelligence picks that up automatically. But if you built a relationship on a key column, it is very important that you do this, or else it will cause issues for you down the road. So I'm just going to go ahead and save it like that. That's going to be fine. Should work fine for this situation here. The next thing that I want to talk about is going to be multiple fact tables and what that looks like in Power BI Desktop.
My name is Nick Lee. I've been working in the Power BI space for about 7 years in both the training and consulting capacity. I've done a lot of great projects with Mitchell so far, and I'm excited about this one too.
When we're talking about Power BI, how often is it that you would see multiple fact tables in a single model?
That's a really good question. I love this question, Mitchell. The big thing about it is not only is it really much of a how often do you see it, it's about a matter of time when eventually it's going to happen. You see, when an organization starts growing and there's more adopters of users using Power BI, then you start getting more questions wanting to be asked, and oftentimes that leads to more fact tables, such as not just sales people want to look at, but they also want to look at maybe budgets or forecasting or returned items or anything along those lines.
So that's really the reason why we built the star schema from the beginning. Is the star schema gives us that flexibility and that versatility into the future so that we can do exactly that. We can expand that and grow it out. If I'm adding multiple fact tables into my data model, does that make it a Snowflake schema?
It depends. It depends. So the whole idea of a star schema that we have is that all of these dimensional tables that we have are surrounding a fact table can filter down the fact table by themselves. Now, when we design our star schema to begin with, that's the whole point of it, is it allows you to scale out later to multiple fact tables. But that doesn't necessarily mean all the dimensions that are currently in your data model are currently prepared to handle every new fact table. So sometimes you have to lean into a Snowflake type schema where your dimensions are filtering down other dimensions before they could then filter down a fact table.
So that is a perfect segue for the demo that Nick is about to do, because we actually are going to present to you a situation where we add an additional fact table, but the fact table itself requires us to actually create a bit of a snowflake in our model. And at the end, we'll show how the two different fact tables are not quite both snowflakes, but it'll make sense when we get to that part. So are you ready to demo?
I'm ready. This will be awesome. I'm ready for it. All right, so here we are inside of the data model that Mitchell's already been building with you guys so far. It looks awesome so far. We have a fact, we have dimensions. Everything works great and perfectly as intended. And now, that user scenario comes up where we need to add another fact table for a multitude of reasons. And this fact table, let's say a good example for us to do would be, we want to also analyze our budget for the upcoming years and analyze our budget for the past years as well. So what we're going to do is we're going to go ahead and load in that table. So we're going to go to get data, and I'm going to go down to text CSV. And here it is right here, already nicely prepared. This table called fact budget. I am going to open that. And I'm going to go ahead and hit transform data to get a better look at this and open up the Power Query editor. Now we're in the Power Query editor and I see what it contains. It has category, segment, scenario, date, and value. All right, so in this case, that value is going to be our budget plan for that. So we could take this, and once I close and apply, load it to our data model and see how it relates in. So I'm going to hit close and apply, and here it is kind of hiding off to the side. If I pull that over, now I can kind of see this table here, and I have, okay, there's an easy relationship I see right off the bat. I could go ahead and relate this directly to our date table. So date to date. Well, maybe I want to fix this data type a little bit on the fact budget table. It also has time involved with it. Let's fix that real quick. So it has date. I switched this to data type regular date, not date time. Now this relationship is going to look even that much better. So date to date looks fantastic. Hit save. Now we had this nice active relationship that goes from our date table to our fact budget table. So now what if I want to filter down this even further? We have a category and we have a segment column. Well, if you remember from previously in this demonstration, we had product table, and the product table contains that category. It contains that segment, right? But if we want to make a relationship directly from product to budget based off of category, we're going to have a many-to-many. Same thing when we go to segment. If we try to use segment related from product to budget, we're going to have a many-to-many relationship. And we can even see what that looks like real quick. So if I move my product table over next to fact budget, just so it's easier to make this relationship, and I try to go category to category here, we're going to see it says it clear as day on screen. This relationship has cardinality many-to-many. It's not going to be working properly for us. So we need to work a way around that. So what we're going to be able to do is use some pieces of that product table and then take those pieces, make another table that will be able to grant us a distinct relationship directly from that new table directly to the fact budget table. So let's jump into that. So as we know, we have category and segment that exists in product. So let's take those values out and create another new dimension out of it. As a reminder, our fact budget table does not have a product ID involved with it. It does not have a product involved with it, simply only category and segment. So what we're going to do is we're going to extract this category and we're going to extract this segment into a new table to create this new dimension. So to do that, I'm going to right click on dim product and I am going to duplicate dim product. Once I duplicate dim product, notice down here it is called dim product 2. I'm going to go ahead and rename that. By a simple double click allows me to rename, and I'm going to call this dim cat seg for category segment. All right, so that looks pretty good so far. And then I'm now going to just keep the columns that I need, which are category and segment. So I am going to select category. I'm going to hold control, click segment to multi-select, right click on either one of those columns and hit remove other columns. After I remove those other columns, now we still have a lot of duplicate values here. So what we're going to do is we're going to create essentially a distinct list of a combination of these values. One way you could do it is you could concatenate the fields together, then remove duplicates, but there's a much easier way to do that. In the Power Query Editor, you can actually just have both columns selected via control click and then right click and remove duplicates, and it will remove the duplicates as if they were concatenated together to make that distinct list of combinations. So far this is looking fantastic. I love how this looks. Now we need to create essentially what's called a surrogate key. And what the surrogate key is going to allow us to do is make that distinct relationship between this table and our fact budget table. Now remember that when you are doing a relationship between tables, a relationship has to be built off of one column. You cannot use multiple columns in a relationship. Now when it comes to merging, you can use multiples. But in our case, we are doing a relationship, which means we need one column. And to do that, I'm going to just create a key column here, and I'm going to go up to the Add Column tab at the top, choose the option for Index Column. I'm going to hit the drop down and choose from 1, so we get a list starting from 1. And now we have this key column. Now the ordering of this table, you could change the order if you want before you make this index, but the ordering is entirely arbitrary at this point. So currently this column is called index. I'm going to rename this column. Just again, simple double click to rename pretty much everything in Power BI. And I'm going to call this my cat seg key, because that's what it is. It's our surrogate key for this. So it's going to be our category segment key. Now, as a reminder, if I go back and look at my fact budget table, that key column doesn't exist here. So I need to bring it in. So what we're going to do is I'm going to have this fact budget table selected. And to bring it in, I need to do essentially what is you would do in Excel, which would be like a VLOOKUP, or I could even just do a table merge if you use the other tools. I'm going to do a table merge and just bring in that one column. To do so, I'm going to make sure I have fact budget selected. Go to the Home tab at the top. Then on the top right over here, I'm going to choose Merge Queries. If I click on Merge Queries, I have my fact budget table as my primary table, and then I'm choosing my secondary table, which is the one I'm bringing in a column from. So I'm going to choose dim cat seg, and then we're going to choose the appropriate columns we're going to base this merge off of. And remember, like I said a moment ago, on table merges, you can actually use multiple columns as a reference for this merge. So I'm going to choose category, and I'm going to hold control and click segment. And then on fact budget, I'm going to do the same thing. And order does matter here. So I'm going to choose category first and then hold control and click segment second. And now it's ready to go. I could change the join kind here to an inner join if I needed to, but in this scenario, it's totally fine to leave it as a left outer join. We're gonna get the results that we're looking for still. As you can see at the bottom, there's still 324 of 324 rows that are matching according to this text here. So this looks good. I'm happy with this, and I'm gonna go ahead and hit OK. Now, when you merge in a table in the Power Query Editor, what it does do is it essentially brings in the whole table as a column, and then you choose which columns you want to expand from it. So what I'm going to do is choose the expand icon on the top right of this column. And then I am going to uncheck everything, including use original column name as prefix, and only have the cat seg key being brought in here. And I'm going to hit OK. And now I have this category segment key. And just to verify that it did work, I can click this little drop down, this filter section for cat seg key to make sure we're getting a bunch of different results. And we are. We're getting 10 different results, which is perfect. Our set looks pretty good. I'm pretty happy with that so far. But we also need to make sure that this category segment table also relates to the product table. Because like I said, we're going to be creating that snowflake type schema where a dimension can filter down another dimension. So I'm going to go up to dim product, do the same thing, choose merge queries, and choose cat seg as my secondary. And I'm going to choose category and segment. And once again, order does matter. So category, then segment. We're going to leave it on the left outer join because that works perfectly for what we're trying to do. And then we're going to select OK. After we've done so, I'm going to expand just like before and make sure only the cat seg key is the column that's being brought over. And once again, just check the little filter items and make sure we're getting multiple filter types. We are. This is perfect. And there's one last thing I want to do on this before we move on here. And the last thing I want to do before we move on is kind of clean up our fact tables now. Now that we have this cat seg key that's involved that we're going to be using to relate to this cat seg dimension, we actually don't need the category and segment columns anymore because they're part of that relationship that's going to be made. So I'm going to go ahead and choose the category and segment columns from our product table, right click and remove columns. So we don't need those anymore. And then once again, I'm going to go to the fact budget table, which also has those category and segment columns, which I don't need. So I'm going to choose category and segment, right click, and remove columns. So this looks great now. The tables are very minimalized to only have what we need, which in this case is that surrogate key coming from the dim cat seg table. And we could go ahead and choose close and apply now. So once all these changes load to all these individual tables that we've made so far, we're going to be able to build our new relationships between these tables. And as you can see, some relationships were automatically added here. So if I look at dim cat seg, I'm going to zoom out some here. If I look at dim cat seg and bring it down, reorder this a little bit, we can see relationships have already been built here. We have our dim cat seg, which is filtering down our fact budget. We're going to double check it's on the cat seg key. It is, looks great. And then also dim cat seg can also filter down the product table on that relationship. And this looks awesome. I'm really happy with how this looks so far. So if we want to get a little bit of a better representation of what exactly is going on in the data model here, we could make new layout views of our data model. So if I open up the new layout, and we pull in the fact budget table. With the fact budget table pulled in, I can right click it and hit add related tables to pull in every table that currently has a relationship to it. And here, only two tables are related to it, which are the dim cat seg and the dim date, which is perfect. This looks awesome. This is one of the star schemas or type of schemas that we have here in the this individual data model, and it is in fact a star schema. And if we pull in another layout, well, we have the other fact table, the sales table. If we drop that one into this layout and hit add related tables, we see three tables now. We have dim date, dim customer, and dim product. But one thing to keep in mind here is these are not the only tables that we're using as dimensions to filter down the sales table. If we look at all tables, we can also see that there's the cat seg is currently have a filter set up to the dim product, which then filters sales. And there's also dim geography, which filters down customer, which also filters down sales, which means that we have right now two Snowflake items within our fact sales table as part of that data model, as part of that schema. So technically speaking, right now, our fact budget table is a star schema, and the sales table, the fact sales table, is a Snowflake schema. So if we pull in those tables as well, so dim cat seg, and lastly, dim geography, we can see how this layout looks now. We can throw a test visual on here to make sure everything is working as intended. So I'm just going to use this one that's currently in place, and we can look at our product. So if I look at the product of, if I look at dim cat seg and look at the category and segment involved with this table. It is working on sum of unit price, which is coming from sales. And lastly, if I look at fact budget, then look at this value item, which is the value of our budget. And we can see it's going to be working on that as well once we get to the appropriate timelines, the appropriate year that exists for that. And then they are working perfectly in tandem together.
That was only 2 fact tables. The fact table for the budget had a different level of granularity, which means we weren't storing the budget at the product level. And so we weren't able to build that relationship directly to the product, which required us to essentially build that higher level category segment table to facilitate that relationship. This is one of the areas where people really struggle with when they're adding additional tables. This is just an introduction. We could have many more fact tables that we add as our Power BI solution continues to scale. So I got another question for you. I think you can help me out with this as well. In this scenario here, we're actually looking at our data right here in this report based on the sales of when something was ordered. So we ordered the product and it's based on the order date. But a lot of times customers have multiple dates in their data model and they want to be able to see it based on the shipping date or maybe by some other date that's there. How do we normally handle that in Power BI? How would you help somebody with that?
Yeah, Mitchell, that's a really good question. And the technical term for this is called a role-playing dimension, but we don't need to harp on that. That's just what the technical term is. Anyways, what you could do is essentially have one of 2, technically 3 ways you could accomplish this. The first way, which is not recommended, which is what I've seen customers do, which is quite unfortunate, is actually build out multiple Power BI reports to account for this. It's a lot more difficult to maintain those separate models and manage them and have to make changes. Would not recommend that way. But there are 2 ways that I would say that I would recommend. The first way is to build out a multiple date dimension per different type of role you want that date table to fill. So a date table would fulfill the role of ship date, and a date table would fulfill the role of order date. That's one way you could accomplish that, and then you could just use those individual fields in your visualizations related to whatever date table you're trying to utilize. Now, the other way to accomplish this is you can utilize inactive relationships on one date table. And so an inactive relationship is the only way you could make multiple relationships between tables, but you only ever have one active, as Mitchell said. But what you could do is if you use those inactive relationships, you could actually write DAX, which is the data analysis expression language that's used in Power BI for our coding. Well, we can utilize this DAX to override the active relationship and tell it to specifically use the inactive relationship. So that way we only need one date dimension to accomplish our goal for that.
So we really have 2 options. Well, 3, but one we don't recommend. Don't do that. So we have 2 valid options. What would be the most common option that we see in the field? And then what would be the recommended option for handling these types of scenarios?
Really the most common way we see clients utilizing this functionality of a table fulfilling multiple roles is actually duplicating that dimension out multiple times. That way you can fulfill whatever role you're trying to do, whether it's order date or ship date or what have you. Now, I will say the most preferred method, on the other hand, is actually utilizing the DAX methodology where you can use those inactive relationships that you create. Now, it is a little bit more setup time and work to get the DAX ones to work properly, but once you do get it set up, it does give you a little bit more flexibility and agility to be able to create a little bit more well-rounded Power BI reports. Okay, so here we are in Power BI. This is the same exact report we've been working in. I'm going to clean up this visual that we currently have on screen to make it work a little better with what we're trying to do. And I'm going to add in one more column. Let's grab the month from dim date. All right, so here we are. We're looking at the sum of all unit prices that was sold in our sales table across all months and years that we have sales for. As you can see, it goes from 2011 to 2016, and every month has its own items of sales. All right, so if we look at dim date, we currently only have one date column in here currently, and this would be, let's say, hypothetically the order date. And what if we wanted to look at this based off of the ship date? Well, our current table doesn't account for that, so we're going to just create something for that to work. So I am going to go into transform data, go into our sales table, and in our sales table we have this date column. So in this date column, I'm actually just essentially going to make a new column with a hypothetical scenario to get it work for ship date here. Let's just say we add every time an item ship, it's always 3 days after the order date, just as an example. All right, so let's make a new column. I'm going to hit add column and custom column. I'm going to call this new column ship date. And then again, it's just going to, we're just going to use the M language here. M stands for mashup, if you didn't know. We're going to use the M language here in Power Query Editor to add that field. So I'm going to use this function called date.addDays, open parentheses. We're going to use the date field, and I'm going to add 3 days. So there's our hypothetical. Our ship date is always going to be 3 days after the regular date. I'm going to hit OK, and just so we're not getting confused on this, I'm also going to rename the date column. I'm just going to rename it to order date. All right, so that looks good. Now we have an order date in our sales table, and we have a ship date in our sales table. Now we close and apply. Now we have our hypothetical scenario stood up here and ready to go. And this table that we see in the background shouldn't change at all because order date is date, so on and so forth. All right, so it hasn't changed at all. And let's just look at what the difference would be like if we switch this to ship date instead. So if we look at the month of January, it's just about almost 509,000. It's 508,896. And if I were to switch this relationship that goes from dim date to our sales table off of order date, and if I move it over to ship date instead and hit save, oh, I need to make sure the relationship is active, hit save, go back to my report view, and didn't like that. Didn't like that. So I think it's a quick fix here. I don't think the ship date was classified as an actual date field. It wasn't. You can see there's no calendar icon. It's a text field. If I switch this to a data type of date, it should resolve our problem. There we go. So remember before we had in January the sale value of about 508,896, and now it's saying January, that same year of 2011, is 394,000. You know, just as a assumption that we can make is we made a lot of sales at the very end of January, therefore the ship date 3 days later did have a different effect on our data of how it's being represented here. So let's work through our examples here on these role-playing dimensions, as we call them, where we can set up multiple scenarios based on the date type of how we want this to display. So let's start off with the first example where we essentially have two separate date tables to accomplish this goal here. So I'm going to start off by hitting the home button, going to transform data. And this time I'm essentially going to do one thing. It's pretty simple, is I'm going to duplicate my date table in this case. I'm going to duplicate date dimension. And the first one that exists, well, currently I have ship date related to it. So I'll just leave it named ship date. So dim ship date. And then the second one we'll call dim order date. All right, so that looks good. Now we have two date tables. I'm going to hit close and apply. Our table is not going to change whatsoever because all we did was add a table to our data model. So I'm going to go to the model view, see dim order date here, and I'm not going to worry about the rest of the model. I'm just concerned with date at this time. So now I'm going to relate instead of instead of ship date to our ship date table, I'm going to relate order date to our order date table. Order date to date looks good. Hit save. Our visual is not going to change at all because we're not using the fields from order date. We're using the fields currently of ship date. So I'm actually going to rename something in here just so we can see a different visual of how it looks. Sum of unit price, I'll just call this shipped for now. So as we can see up here in the category title, it says ship. And then I'm going to duplicate this visual and I'm going to switch some fields around now. So as you can see, year, if I hover over year, it says dim ship date. Hover over month, it says dim ship date. If I switch it to the year and month of the order date, so if I drag in year in my table, make sure it doesn't summarize, and then also drag in month. Now we have two different values being displayed. I just need to fix the sorting of this month column. Sort by column, sort by month number. There we go. Now, this is no longer called sum of unit price shipped. This was sum of unit price by order date. And we could see the difference that one relationship makes, whether we sold it based off of order date or we're calculating it based off of ship date. So we could easily see the difference here. This is that methodology by using multiple tables to accomplish this goal. Now again, what if we wanted to use one table to accomplish this goal? We could absolutely do that as well. So this is going to be utilizing that DAX method. All right, so let's run through that method as well. I'm going to start off with I'm actually going to grab one of these visuals, go to a new report page here, paste it, and use this one to go off of. So currently we have looking at the sum of unit price for order date. Okay, and if I go into my model view, we're going to pretend here that this ship date table doesn't exist, okay? We only have order date that exists for this example that we're going to make the DAX calculation based off of, all right? So what we're going to do is we need to get that inactive relationship in place so we can call it when we need it. So if I go ship date, drag this ship date to date from our order date table, drop it, and hit save. Notice now the relationship that's currently being shown, if I zoom in a little, there we go. The relationship that's being shown is a dotted line. That's called an inactive relationship. You can also see over here on the properties pane on the right side, it says this relationship is not active. Whereas if I choose the other relationship, it is active and it is a solid line. So now I can go back to my report view and let's make some measures. So best practice anyways, whenever you're doing any type of aggregation or measuring, you should use measures. So we're going to make some measures here, just a couple. So I'm going to right click on sales and I'm going to choose new measure here. Now this isn't necessarily a course to teach you guys how to write DAX, but this is assuming you already know DAX or have a foundation or check out some of our other videos on it. But we're going to write some DAX. I'm going to hold control, make this a little bit bigger. That looks good. And this first one I'm going to call total sales order, because this is the one that's going to be based off of order date. Now, to make it based off of order date, I technically have to do nothing special. All I have to do is sum up the unit price column, and it'll show us that value for order date because the relationship for that already exists. So if I do sum of the unit price, hit enter, it should look exactly the same as this column in this visual is if I add it. And as you can see, it is exactly the same because it's essentially doing the same thing. It is just summing unit price. All right, but I'm going to get rid of this sum of unit price order here. All right, so let's make another measure. I'm going to right click sales, new measure, and this one is going to be based off of the ship date. So I'm going to call this one total sales ship. All right, so now I'm going to use a function called calculate. This is one of the bread and butter functions that exists in the DAX language. The more you write, the more you're going to utilize it. But essentially, I'm going to say, I want to use the total sales order measure that already exists, except instead of using it for order, I'm going to use it for something else. And in this case, the other thing I want to use it for is this use relationship function. What the use relationship function does is it allows me to specify a relationship that I want to use rather than the one that currently exists. So in this case, I'm going to choose my inactive relationship, and that inactive relationship consists of two columns. The first one is this one is the ship. So the first column is the date from ship date, and the second one is called ship date from sales. So these are the two columns that exist in my relationship, the ship date and the regular date. Oh, I actually chose the wrong one here. Remember, we're pretending that the dim ship date doesn't exist. So that's my fault. So we need to use order date instead. There we go. Looks good. So now if I add this back in here, in this visual, we get that 394,000 value. So now we're comparing order date to ship date as far as total sales goes using just one date table to accomplish it. Whereas on our other page, we have to use two separate tables with two separate dimension types to accomplish the same goal.
What I want to talk about next is very important. So I brought in Manuel Quintana. Manuel's been here with us at Pragmatic Works for over 10 years. You've seen him on our YouTube channel. He's an expert. And what I wanted to ask him is really a question about the data analyst of the future. We just learned how to do all of this in Power BI Desktop.
Yeah.
So the question I have for you, how do I future-proof myself as a data analyst, right? We did all this here. This is great.
Yeah.
But I've been hearing about a lot of other things that are coming out.
Yeah, I mean, you can't escape the fabric, right? Fabric's everywhere. When we're talking about Power BI service and where it's going, the direction. And the good thing is, right, I know it's nice to know this after you've spent all this time and working through this, that everything you've learned, when we're talking about fabric and this idea of a fabric engineer and bringing in data, we still are having those exact same conversations. We're bringing in data. We're looking and trying to define and understand, is this a dimension? Is this a fact? We're identifying our tables. If we need to break out tables into dimension tables, we are still having those same conversations. These are conversations that have been around for decades now, but they still are tried and true. And Fabric still follows that idea of being built on top of a star schema. There's a lot of pieces to Fabric, but in that concept of just looking at the data, bringing it in, and working with it, all those foundation elements that you guys covered still apply completely.
So I've heard a lot about Microsoft Fabric, and Microsoft Fabric seems pretty intimidating. At first glance, if I get in there, there's, like you said, there's a lot of moving pieces. There's building notebooks and PySpark. There's machine learning. There's data flows. There's a data warehouse. There's a lake house.
Yes.
I get a little bit confused what I need to do there. So as a data analyst of the future, and we're talking about all those different pieces, it's really intimidating. I mean, what are your thoughts around that?
It can be when you take it as the whole picture, but that's the idea, right? Fabric is an end-to-end analytical solution. So we're really talking about getting multiple personas, different individuals within the organization that are going to take on different pieces. So when you take on, look at everything, that can absolutely be a bit overwhelming, right? But you don't need to be a data scientist. You don't need to be an engineer. You don't need to know how to do Python and do notebooks. If what you know is Power BI and you know semantic models, at the end of the day, when you work with, let's say, like a lake house and you see how to bring in data, the delivery mechanism for that analytical view of the data visually is still a semantic model. You're still connecting with Power BI to a semantic model, and you're viewing that information and you're sharing those reports with your users. So the end delivery product remains the same. And those skill sets that we learned today in the session itself, they transfer over into, some of you might be familiar with it already, but like Data Flows Gen 2, right? Data Flows have been around, but now we have Gen 2, and it is just the Power Query Editor. And there's other deja vu things too, which we might kind of see here in a little bit.
Okay, and we're going to get into a demo in just a second. We're going to look at some of these capabilities. But what's cool about this is that although there's a lot of things in Fabric that are super important to learn as a data analyst of the future, we don't need to know all of those right out the gate. So as long as I understand the lake house, which is not a very difficult concept, and I understand the semantic model, which is what we're building in Power BI Desktop, I really can start to make that move in that migration over to Microsoft Fabric.
Yeah, absolutely, right. I mean, in a very simple manner, you spent today connecting to CSVs and you loaded and duplicated all that data into Power BI. Effectively, you made your own little database in there and you defined the tables. We're simply scaling this out. When we think Fabric, we're scaling this out, and it's meant to be an organizational resource. So instead of taking those CSVs and loading it into one semantic model, we load it into a lakehouse, which at the end of the day is just a centralized storage location for the entire organization. You can think OneDrive for your data is a very common term here. But you've taken all the same work, all the same effort, but now you can place it in a way that you can very easily share this work with everybody or anybody in the organization. Of course, security is there. You can pick and choose who gets the benefit here, but that's the idea. It's a built-in, out of the box. You don't need to worry about it. Somewhere where you can store this, model it, relationships, create measures, but now it's very easily accessible, and there's some really cool benefits when you take the opportunity and really get into using something like the Lakehouse and taking advantage of that one lake storage.
Awesome. I have actually a lot more questions for you. I have a few more questions for Manuel, but before we jump into any more questions, can you take us to Fabric and maybe show us a semantic model that's already been developed?
Yeah, absolutely. And then this we can also kind of look at and explore some pretty interesting features. There's been, as a software as a service and Power BI, there's things changing, it feels like every single day. So just remember, as you're looking and watching this, even an hour after this, there could be something new. It's very exciting. And we're going to show you some very, very new things that I think really add some nice enhancements to this process of I'm brand new. One thing that we were discussing before also is really helpful is I've taken the time, I've created a semantic model. Do I need to redo everything?
That's going to be a question that
Yeah.
we cover here in just a moment.
And we'll see a bit of that
Very good.
right now when we go and explore. So why don't we head over to the machine right here. Let's take a look at the Fabric and a Lakehouse. All right, we're over here. Browser choice in my workspace inside fabric.com, powerba.com, whatever you prefer there. And right here at the top, we'll just kind of zoom in. I've already created a Lakehouse here, as you can see. There's some other elements we'll get into here, but in this Lakehouse, you're going to see it's called the Lakehouse Explorer. I have a couple of tables, right? And it looks kind of like almost like you're in SQL or something of that nature. It's just a table. Or if you're going into the table view inside Power BI, it's the same kind of idea. Here's my table. I got some columns, and you can preview the information right here. Now, how did I load this information in? Well, this is going to seem pretty darn familiar. If I return back to the workspace, well, look, I have this item here. This is a data flow Gen 2. Anyone coming from a data flow background is going to feel very, very familiar. But if someone hasn't done any data flows, this probably is going to have a degree of semblance of what you covered in today's session. It's just the Power Query Editor, but it's online. So you can see we have the full access of the Power Query Editor. It's a UI-driven experience, and you can just move through the interface and leverage what you need to do, all the while it's creating this Power Query code for you. So I've gone through, I cleaned up these tables, and I defined a destination here for each of these tables, and I simply ran this, and it loaded those very tables into the actual Lakehouse itself, and that's what we're seeing here. So literally, the process you guys went through, if you wanted, you could have done the same thing right here inside of a Dataflow Gen 2 and just set your destination to the Lakehouse, and you're already moving down that pathway of leveraging this organization-wide OneLake, this organization-wide storage element, which Lakehouse takes advantage of. And on top of that, we can also go through the process because that's our Lakehouse. And there also is a SQL piece, which is pretty fun, but that's a different story, different day. But we can also access another very similar experience here. As we see, there is a default semantic model. If we just close out here, it's automatically part of this. Just so you know, also you can create your own semantic models from it, but you can see it's just a semantic model. My tables are going to be listed here on the right-hand side. You can click on it, explore it, and if you wanted to, there's a little more involved here, but you can access the actual SQL endpoint. And if you go to the modeling layouts, this also, once again, might feel a little bit deja vu. I have a list of my tables, and I have the availability here to draw relationships between these tables using the respective key columns. And I technically can also add calculated measures here as well. So that's a quick little foray into the Lakehouse, loading it with Dataflows Gen 2, Power Query Editor Online. And we have this experience here, very similar to how you can model inside Power BI Desktop, but all online, all within the browser experience itself.
Thank you for that demo.
Of course.
You showed us a Lakehouse. The Lakehouse looked a lot like my data model in Power BI Desktop. It looked very similar, in fact. And the way we got the data into that was using Dataflow Gen 2, which looked just like Power Query. Okay. And then you showed us the semantic model, which looked just like the model view or that relationship view inside of Power BI Desktop. So this isn't really that intimidating at all once we get in there. Now, I don't know how you build it. I didn't see the actual process of how you did it. So if I'm a new person, I'm watching this class, I'm like, this is great, this is exciting. You now have me feeling pretty comfortable about Fabric. Yeah. Where when I walked in here, I was a little intimidated. How can I go a little bit further with Fabric? I want to learn about this.
Absolutely. There's definitely a lot of different paths, but one of the most immediate things you can definitely dive into is on our on-demand learning platform in partnership with Microsoft, we do have a Fabric Analyst in a day. Mm-hmm. And as you can tell by the term there, it is focused on that analyst perspective, that persona. So it's in these very exact topics we're discussing. Lakehouses, OneLake, Dataflows Gen 2. Okay. And we sneak a little bit of pipeline. It's extra, but it's really a cool thing to investigate as well.
So free.
It is free.
Right now on the Pragmatic Works for life, you can sign up for the Analyst in a Day, the Fabric Analyst in a Day, which is designed to ramp somebody up who is an analyst to using Fabric.
It's all there.
100% free in our partnership with Microsoft.
Absolutely. It's definitely a solid foundational beginning to really grasping, especially for an audience coming from a Power BI background, a really solid foundation into Fabric. And then you can extend into other areas if you like.
What if I do want to go deeper into those topics? Is there anything that we have around that?
There is a couple of extended options we do have, right? Mm-hmm. We have our public Fabric bootcamps, which are 4-day events, so they're pretty involved. Mm-hmm. And we definitely have to keep up to date with the changes. So we're trying to constantly update that and keep that into what's new. And as well, of course, from a public perspective, there's always the opportunity to do like private engagements to customize Fabric trainings. Yeah.
Excellent. So we're excited about Fabric. We've seen Fabric. I do got another question for you. Pretty important. we just did all of this in Power BI Desktop. It was really easy. I didn't have to take these extra classes. What are the benefits of Fabric? Why would I do this in Fabric instead of doing this in Power BI Desktop?
Yeah, there's definitely multiple bullet points here, right? One I'll just put right out there because it's kind of something everyone here will catch and they'll see if you're coming from a Power BI background, is this new data connectivity mode that's called Direct Lake.
Okay.
So we know there's live connection, there's direct query, and there's import. Well, now the new kid on the block is Direct Lake.
Okay.
And it's bringing the best of both worlds. So when you take advantage of Lakehouse and you take advantage of the semantic models that are by default as part of this process, you can get a new query mode, and it is by far the most performant that you can get into. It's
Okay.
really awesome. We dive more into that in the Analyst in a Day and all those trainings as well.
So I would think with Fabric, I can have bigger data models, like from
Yes.
a scalability perspective.
That is the whole idea. If we remember, like the common term we're using here is it's an end-to-end analytical solution for the entire organization. So scope and scale is absolutely what we're talking about here. And also, we mentioned like the idea of following star schema and these kind of classical modeling techniques. Well, in the same way, we're talking about this as a data warehouse. We're talking about something that's meant to be a one version of the truth, where we build this out so it has a holistic view of the whole organization. So all of our reports, all of our reporting users can know with confidence that they can use this data for their reporting needs. So that is with that whole thing with the whole underlying one lake and this centralized storage, all wrapped around Entra security. Nice, clean, simple, and it can really help reduce data redundancy in your environment in Power BI, which has actually been a problem for a long time. Just duplicate data sets, redundant information. One lake can really streamline that process.
So we're going to take a look at that in just a moment. We're going to take a look at the model again, and we're going to look at this idea around the redundancy and how we can work around that. So we've talked about scale. We've talked about the security a little bit as well.
Yep.
Some significant security enhancements that we can get by having this in Fabric. The other thing is when I'm building a Power BI model today, I'm really building a Power BI model for the purpose of analytical purposes only.
Yes.
Dashboarding only. But what if I built a model inside of Power BI Desktop and I have a data scientist or a data engineer that wants to they really can't access that data. So with Fabric, what do I get?
Absolutely, that's perfect. I mean, it fits into that kind of conversation of an end-to-end solution. And there might be very well some of you here who maybe are new to the whole Power BI experience and everything was new here, Power Query was new here, but maybe you know SQL. You know, maybe you were more familiar with Apache Spark and using notebooks. The best part is once we create these tables like we saw in that lakehouse, you now have access to use this with a SQL endpoint. You can bring this into Apache Spark using Python. You can do machine learning experiments against it. There's a nice standardized unified format that comes with these tables that you don't have to do anything. It's a managed experience. You just use data flows, make a table, and now every other type of role in your organization can take advantage of that same exact table, not just for Power BI, but for so many other potential workloads.
Yeah, and that's the big premise around Fabric and what was before Synapse Analytics is this unification across the organization for different roles.
Yep.
So as a data analyst, I can stay in my lane, really. I can stay in with lake houses and with the semantic model and just keep doing what I've already been doing inside of Fabric, but now other people can also access that data. They can enhance it, they can enrich it. It really gives us a lot of capability that we don't currently have. So all of that is great. I love that. I do have one more question though. So I'm finding out all of this information maybe after I've done a whole bunch of work in Power BI Desktop. I've built a really good model. I've done a lot of enhancements to it. I love my model. If I've decided now that I want to move to Fabric, I've taken that free class that you mentioned on the platform. I feel really comfortable with it. I want to build a proof of concept. Do I have to do everything from scratch? Do I have to start over?
So the quick answer there would be no. You don't have to.
All
That's,
right.
you know, you can just stay with what you have. You guys developed a semantic model in this session. You can actually deploy that semantic model out to the service. There are some prerequisites I'll briefly can show you here. But you can integrate that semantic model with OneLake, which gives you some capabilities, right? You do get the full breadth as of right now, because that is a preview feature, but you do get the full breadth of all the features and capabilities should you actually bring it into a lakehouse in the more organic fashion, let's say like through Dataflows Gen 2, which, don't forget, right, it's Dataflows Gen 2, it's Power Query. You can literally have on one screen your Power BI desktop report open, and then a browser with data flows Gen 2 open, copy this and paste it. And literally, that's all you need to do. It's Power Query. So you can literally take 2-3 clicks and you've now recreated the entire process, and you just now have to set a destination, whether that be the lakehouse or the warehouse, but you just set a destination, run it, and now you have tables right inside that lakehouse. So you have a couple of avenues here from like a migratory perspective.
The only other thing I have, and you kind of mentioned it a little bit, is I wanted to ask a little bit more, and I know we're going to jump into just a real quick demo here, if you can show that, about this direct lake capability. So direct lake is new. So here's the deal. We can build our models in Fabric, our lakehouse, our semantic model in Fabric. So now I'm really using Power BI Desktop more as a reporting tool.
Correct.
Right?
Yes.
If I'm opening up from Power BI Desktop, I'm opening it up and I'm connecting live, which is not the same as direct query. I know direct query is a kind of a bad word in a lot of organizations. The performance is not great.
Yeah.
Direct lake is different.
Correct.
Direct lake is communicating with a semantic model in Fabric that they talk to one another. They're the same language.
They're living in the same real estate.
And Microsoft is taking that, putting it in memory when we access it. So the performance is awesome. It's amazing. Larger models. So can you show us one last demo here of just kind of how we can use these semantic models, our lakehouse, to reduce redundancy in our Power BI reports and maybe connect to other data that's elsewhere in our organization?
Absolutely. We can dive right in. And like I said, some of these things are preview right now, so definitely could change. But very exciting items to look at. So let's head back over into that workspace and take a look at this as an example. All right, we're going to take a look, same workspace that we were in before, right? But we're going to take a little focus on the very bottom here. I have just a semantic model. It mimics somewhat the data you guys worked on today, but there actually isn't any modeling effort done. It's just the tables. But you can see if I just click on here real quick on the right-hand side, the list of tables. So I've taken time, I've connected to it. This is an import, so all this data is part of the semantic model. So the idea here is the product table, right? I don't have that in my lakehouse. If we go and visit this, it is missing. So I want to bring in the product table. What are my options here? Yes, I could just start from scratch, data flow Gen 2, bring it over, but that is redundantly bringing that data over. I already have it. We just saw it. It's available to me. This is what OneLake is all about. If this data lives anywhere in this Power BI service, we can share this with an organization, we can reuse this, and we can work with it as if it exists right there, as if you had taken the time to bring it over. So if we go over to this actual semantic model, there's a couple of prerequisites. You have to turn this on at the tenant level setting. But if you go in just to the settings of this, and once again, fresh off the press, is like 2 weeks old, you do need to ensure that your model is in this large semantic model storage format, but there's this OneLake integration. You can see the little preview tag there, but you flip this switch, you do need to go ahead and refresh the data set, whether that be a scheduled or a manual refresh. But once that's done, it effectively creates a little structure inside OneLake, just something that we can now see. So I've done that ahead of time, so it's taken care of. But this means now, if I'm like, hey, you know what? And now I could be in any workspace, anywhere I want, at different lakehouse. And I say, I know that Mitchell created this product table. I want it. All I need to do is adventure over to my lakehouse, go over and use what is called a shortcut. And you can see there's some other cool options around it. Once again, we definitely tackle this stuff inside the Fabric Analyst in a Day and other trainings. But I can just go to OneLake. And this literally shows me all the lakehouses, warehouses, and OneLake integrated semantic models that I have at my disposal. And you'll see right there, second from the top, is that very semantic model. And I can simply click on this, hit next, and I am given a list of all the tables that exist in that imported model. As of right now, imported semantic models are required for this as some of the limitations that exist. So these are literally the tables we just saw. And I can simply go here and say, you know what? I want this product table. I want this to be part of this lakehouse. And you could rename it at this juncture if you like. But now I literally have a fifth table in here. It is called product. You can explore this with SQL. You can go ahead and if you wanted to create a semantic model. So if I actually went over here, you can see it's loading up. It'll be part of the default semantic model. I could add it to a new semantic model. I can use T-SQL against it. I could bring this into a notebook, but I'm not duplicating the efforts and like redundantly storing this data once again. It's here. It's available for me to take advantage of as I see fit. Not just for the analyst, but like we were talking, all of the other roles that we possibly would have want to take advantage of this.
All right, thank you guys for joining us for data modeling in Power BI. We wanted to introduce Fabric. It's such a big topic. It is, all of the buzz right now is around Fabric, but there's a lot of intimidation there. So thank you so much, Manuel, for joining us and introducing this, at least at a very high level. We're going to have a Q&A immediately after this event today. So if you've been watching us live and you have questions, and I know you do, make sure to join us on that Q&A session. If you're watching this in the future, it's been recorded, and it's still going to be recorded. It's going to be out there. So take a look at our YouTube channel. Take a look at that Q&A. I think we're going to get a lot of great questions in that. That's going to be awesome. And again, thank you guys for joining us, and we'll see you next time.